Has China done what even America has not? Recovering orbital rocket boosters through two different methods? Could Xi's new reusable rocket breakthrough begin eroding one of America's biggest advantages in space access? With nearly 1,900 satellites now in orbit, is China's growing space network tracking US forces across the Pacific? Could US aircraft carriers be tracked from orbit, as China builds a vast satellite network to guide long-range weapons? Is Trump's already strained Navy now operating under Xi's watchful eyes, with Chinese satellites monitoring ships and aircraft? China's reusable rocket breakthrough could now reshape the military race in space, giving Beijing a way to launch satellite constellations faster and at lower cost. On August 19, LandSpace recovered the first stage of its Zhu-Q3 rocket on land, after the vehicle successfully launched a satellite into orbit. This marked China's first land recovery of an orbital-class rocket booster after launch, using a controlled vertical landing supported by deployable landing legs. China has now recovered orbital rocket boosters using two different methods, demonstrating both land-based vertical landings and ship-based sea recovery operations. Zhu-Q3 landed vertically using landing legs, allowing LandSpace to recover the booster on a designated landing site in Gansu province. Long March 10B was caught by a net at sea, using a specialized recovery ship to capture the returning booster above the water. China is the first nation to achieve both orbital booster recovery methods, combining a vertical land touchdown with an ocean-based net capture system. The United States has not demonstrated both recovery pathways, despite SpaceX pioneering routine booster landings on land and drone ships. America still leads in total booster recoveries, with SpaceX operating the world's most mature, reliable, and frequently reused rocket launch system. Interestingly, Zhu-Q3's landing legs and stabilizing fins resemble those used by SpaceX's Falcon 9, highlighting how closely China's new booster mirrors the US design approach. Zhu-Q3 and Falcon 9 are broadly similar in overall size, with both designed as large two-stage launch vehicles capable of deploying payloads into low Earth orbit. Zhu-Q3's stabilizing fins resemble features found on the US rocket, helping guide the returning booster during atmospheric descent and recovery operations. Falcon 9 has a significantly higher stated payload capacity to low Earth orbit, lifting up to 22.8 metric tons compared with Zhu-Q3's reported 14.2-ton capacity. Zhu-Q3 uses stainless steel as its primary structural material, differing from the aluminium alloy construction widely associated with Falcon 9's rocket body. LandSpace says stainless steel could make production cheaper, potentially lowering raw material and manufacturing costs as it seeks to scale up reusable launch operations. Methane oxygen propulsion reduces soot and coking during operations, helping engines remain cleaner during the repeated use needed for a reusable booster system. Cleaner propulsion could make repeated rocket reuse easier, reducing maintenance requirements and improving the turnaround time between launches. China's reusable rocket breakthrough could have much bigger military consequences, because cheap and frequent launches can transform the pace of satellite deployment. Reusable boosters could lower costs and let Beijing put satellites into orbit much faster, allowing China to replace losses and expand constellations at scale. That could speed up deployment of large distributed military satellite constellations, strengthening China's intelligence, surveillance, communications, and targeting capabilities in space. US Space Force officials warned that China built the expanding network to track mobile American forces, including warships and aircraft operating across the Pacific. China had fewer than 100 satellites in 2013, when Xi Jinping came to power and Beijing began rapidly expanding its space-based capabilities. Beijing now operates roughly 1,900 satellites, reflecting a dramatic expansion of China's orbital infrastructure over little more than a decade. More than 500 are remote sensing satellites, designed to collect imagery and other data from Earth for civilian, military, and intelligence purposes. The network can track mobile forces across the Pacific, providing China with persistent observation of ships, aircraft, and other military movements. US aircraft carriers can be monitored from orbit, giving Chinese forces information that could help identify a carrier's location and activity. Destroyers and cruisers can also be tracked, extending China's space-based surveillance reach across the wider US Navy surface fleet. US aircraft deployments can be monitored, allowing Beijing to observe military air activity around the Pacific and nearby regions. Satellite data can cue China's long-range weapons, linking orbital surveillance with missiles and strike systems designed to hit distant targets. Washington is now openly calling for new anti-satellite weapons as China expands in orbit, reflecting US concerns over Beijing's growing military space capabilities. Reusable rockets could also help China challenge America's edge in global launch costs, allowing Beijing to compete more aggressively in the commercial space sector. China's two recovery breakthroughs may now begin eroding a key US edge in space access, as reusable launch systems promise lower costs and faster deployment. China is reportedly being urged to speed up plans to mobilize civilian ships for military use in future wars. An article in Defense Industry Conversion in China said civilian vessels could provide critical support for Chinese military operations during wartime. The article said China's growing maritime security requirements and military needs had made the rapid mobilization of civilian ships increasingly important. Experts said Beijing should draw lessons from Britain's 1982 Falklands War experience, according to the South China Morning Post. Li Jin said, and I quote, "As China's national security and development interests continue to extend into the maritime domain, the growing demands for maritime rights protection and military operations have increasingly highlighted the critical role of civilian ship mobilization." Unquote. Britain had mobilized dozens of commercial ships within days during the Falklands War to transport aircraft, fuel, troops, and other critical military supplies. Li urged China to build a detailed database covering civilian ships, including their speed, cargo capacity, ownership, and available crews. The proposal also called for detailed plans covering command structures, communication systems, and the rapid mobilization of civilian ships during wartime. China was urged to conduct more exercises to test whether civilian vessels could effectively support military logistics and sustain operations during wartime. Experts also called for new civilian ships to be designed with features that would allow them to be rapidly converted for military use when required. The Zhenhua 33 semi-submersible vessel was cited as an example of a civilian ship that could offer significant dual-use potential during military operations. China also recently sparked debate after modular missile systems were reportedly seen aboard the Zhongde A-79, raising fresh concerns over civilian-military integration. These developments raised questions over whether Beijing could eventually transform parts of its massive merchant fleet into combat support or even frontline platforms. China's sixth-generation fighter has now shown off unprecedented maneuvers in new footage, offering another glimpse of a large tailless aircraft still under flight testing. The footage showed the Chengdu-developed aircraft executing a complex high-alpha move, moving through an extreme nose-up attitude before a sharp descent and recovery. The aircraft enters high-alpha flight at a demanding angle of attack, where airflow over its wings and control surfaces becomes far less stable and predictable. It then pitches over rapidly before entering a steep descent, requiring the flight control system to manage a sudden and dramatic shift in aircraft attitude. The jet transitions from high-alpha flight into a near-vertical dive, a move that can rapidly increase speed while reducing the pilot's margin for error. It performs a sharp recovery while maintaining aircraft control, avoiding an aerodynamic stall or loss of stability as forces rise during the pullout. The aircraft must rapidly manage changing airspeed and energy, preventing it from gaining too much speed in the dive or losing too much for recovery. It continues climbing immediately after recovering from the dive, showing that it retained enough energy, thrust, and control authority to regain altitude. However, recovering from the steep dive may be the most demanding phase of the entire maneuver, because the aircraft must regain control under rapidly increasing aerodynamic pressure. The flight control system must manage rapidly changing angles of attack, shifting the jet from an extreme nose-up condition into a steep descent and controlled recovery. It must maintain control as airflow becomes less predictable, particularly around a tailless airframe that lacks conventional horizontal and vertical stabilizers. The aircraft has to control rapidly changing airspeed during the dive, preventing excessive acceleration that could strain the airframe or complicate the recovery. It must withstand potentially high G-loads during recovery, as the jet pulls out of the dive and rapidly redirects its flight path upward. The maneuver must remain within aerodynamic and structural limits, ensuring high loads and unstable airflow do not damage the aircraft or cause a loss of control. The jet also has to preserve enough energy to climb after recovery, demonstrating that the dive and pullout did not exhaust its available performance margin. The maneuvers are even more striking given the fighter's unusual size and tailless design, a configuration that can aid stealth but creates serious control challenges.
Upgrade your news experience with the all-new HT app. Download now.